Welcome to a lesson on simplifying rational expressions. In this lesson, you will be simplifying expressions that look like fractions where the numerator and denominator are both polynomials. The goal is that you will be able to multiply and divide rational expressions. So we will get started. I have 3 warm-up problems for you that hopefully you've done, and I've asked you to factor these 3 polynomial expressions. The first one I factored using the box strategy. I put 2x squared up in the top left and 1 in the bottom right. I then multiplied these two together and I got 2x squared. And I'm looking for 2 expressions that multiply together to equal 2x squared, but add together to equal negative 3x. So I came up with negative 2x and negative 1x, which I then put along the diagonal. I factored out of the top the common factor that they share of 2x, and I filled out the rest of the box. 2x times x being 2x squared. 2x times negative 1 is negative 2x. X times negative 1 is negative 1x, and negative 1 times negative 1 is positive 1. So I have now written my expression in factored form. These expressions are equivalent, but factored form is the one we'll be using a lot in this lesson. 4x squared minus 9, I notice this to be what we call the difference of perfect squares. So we have 2 perfect squares, 4x squared and 9, that are being subtracted. And because of that, I know how to factor as the square root of 4x squared in the first spot, the square root of 9 in the second spot, a plus and a minus sign. Hopefully you're remembering the difference of perfect squares. And then we have this last one. I decided to use backwards FOIL because the only way to get 5x squared is 5x times x, and the only way to get 1 is 1 times 1. So I felt like this would be very reasonable to do without the box. I then proved that it's correct by doing the first 2 multiplied together. Checked out. Outside and inside, these like terms add together to equal my linear term of 6x, and last 2 is 1. All right, so now we're going to jump into our lesson about simplifying rational expressions. We have 2 terms that we want you to pay attention to. What is a rational expression? Well, it's the quotient of 2 polynomials. Just by way of reminder, 70 over 80 is a rational number, you'll remember, because a rational number looks like a fraction. The fraction bar really means divide. Thus the word quotient. When we write something in simplest form, we write it as an equivalent expression where the numerator and denominator have no common factor. So 70 over 80, if I divide both of these numbers by 10, 7/8 is my simplest form. So that's just a review of what you already knew about rational numbers, but now we're bringing it into the world of polynomials. So this is a rational expression, because I have a linear binomial on the top and a linear binomial on the bottom. What we can do to simplify it is we can factor out a common factor of 3 from my numerator, giving me 3 times x plus 2. Factor a common factor of 6 out of my denominator, giving me 6 times x plus 2. And then I crossed out these common factors because any number divided by itself is 1, so I can cancel those out, leaving me with 1/2, 3/6 being equal to 1/2. Now, there's something really important when you have, anytime we're talking division, right? Anytime we're talking division. If I wanted to divide by 0, I'm wondering what would that look like? So I'm just going to refresh your memory here, that if you had a number like 6, and you typed it into your calculator, is 6 divided by 0? You would get something that either says undefined or meaningless or not a number. You would get some message that indicates there's a mistake, there's an error. Now, there's We can explain that. Hopefully your earlier grades teacher explained why we can never divide by 0, but it's important for you to know we can never divide by 0. So because of that, whenever we have polynomial expressions, we have to look at my denominator, and we have to say that 6x plus 12 can never equal 0. Because if this expression did equal 0, you would be doing a mathematically erroneous process. We don't divide by 0. So now I'm going to just solve this by subtracting 12 from both sides. So I say 6x cannot equal negative 12. I'm going to divide both sides by 6 now. And that says x cannot equal negative 2. So my restriction on the variable is that x cannot equal negative 2. So that's your restriction. And my simplified expression is 1/2. All right, so this is the focus of what we're going to be doing today. We're going to be factoring things. We're going to be looking for common factors that we can cancel out. We'll be simplifying, and then we'll be stating any restrictions that we have. So we'll move on to the next example. And here is our example. Negative 6x cubed y squared. Now that's a monomial on the top, isn't it? Over 15x squared y, another monomial. What I've done is I've rewritten my numerator, noticing that 6 and 15 are going to have a common factor of 3. So I've just called it negative 3 times 2. X to the third power, I just expanded it. Y to the second power, I expanded that. In my denominator, I wrote 15 as 3 times 5, expanding x squared and writing down my y. Now I'm going to get a line tool, and I'm going to be crossing out things that I can. I'm going to be canceling out a 3 from both the numerator and denominator. There are 2 x terms that I can cancel out, and there is a y term that I can cancel out. And now I can write my simplified form. Let me look at my numerator. I have negative 2x y in my numerator over 5. That's what I have as my simplified fraction. I will put my line down so that we know that this is a fraction. And as far as restrictions on my variable, someone might say, well, there are no restrictions because 5 is not equal to 0. But be careful, there was an x and a y originally. And so we have to denote those as restrictions, that neither x nor y can equal 0. So my 2 restrictions are x cannot equal 0 and y cannot equal 0. Those are our restrictions. And so we'll do one more here on this lesson, and then we'll have you try some. And we are simplifying our numerator by factoring out a 2. I'm simplifying my denominator by factoring out a 3. And I'm noticing that, wow, these things look so close, don't they? A minus 5 and 5 minus a. Are they the same thing? Well, no, they're not the same thing. Because, and let me rewrite this, because I can do 2 times a minus 5 in my numerator, but in my denominator, I can rewrite this as 3 times negative a plus 5. Do you see that? Putting my a term first, it's negative a plus 5. Now, why is that important? Because I can now see, if I were to take, and let me grab my highlighter tool, if I were to take this expression right here, and I were to multiply each term in here by a negative 1, I would in fact get this denominator, wouldn't I? So what we can do is, when we notice that, we can cross them out. We absolutely can cross them out. But we have to remember to put a negative 1 somewhere, either up in the numerator or down in the denominator. So what I'm trying to say is that anytime you see an expression where it's like a minus b times b minus a, this is another name for negative 1. So knowing that, what's -1 times 2/3, this is going to be our answer as far as simplifying the expression. My answer is going to be -2/3. That negative can go either in the numerator or in the denominator or out in front of the fraction, but it can only go there once, right? Now, as far as restrictions on the variable, what can a not equal? So this is when we're really looking at the denominator. We know this denominator can never equal 0, right? So therefore, a cannot equal what? A cannot equal 5. Do you see where I got that from? I use mental math. And I said that 15 minus 15 would equal 0. So if a were 5, this would equal -15. That's how I know that a cannot equal -5. Another way to do it is to look at your factored form. 5 minus what number would equal 0? So those are your restrictions, and that's a little introduction to simplifying rational expressions.